This is Mr. Fakada. In this video we are going to talk about how to calculate the normal force, frictional force, the resultant force, and the acceleration of a mass acted by a certain mass, a certain force, which is at an angle of 37 degrees in this case. Surface is rough, coefficient of friction is known, and we are going to find the normal force, the frictional force, the resultant force, and the acceleration of this mass. Let's dive in. The question says calculate the normal force Fn, the frictional force small f, the resultant force Fr, and the acceleration A of 10 kg mass on a rough surface of coefficient of friction 0.5 acted by 100 Newton force as shown below. Here is the case. So there is a mass, a rectangular mass here. This is the mass. It is 10 kg. It is on rough surface, meaning the surface of the mass and the surface that supports the mass. Here there is rough. It's a rough surface, and the coefficient of friction is given 0.4. So this mass is acted by a force F of 100 Newton. 100 Newton, which the force has both components, the x component and the y component. So now this is the force, then this force is F of 100 Newton applied, and this has two effects, the horizontal effect, this Fx, and the vertical effect, that Fy. So from your vector resolution, you know the y component of this force is equal to this force times the sine of the angle, so that gives you 16 Newton force upward, and the x component of the force is gonna give you F times the cosine of 37 degree, 100 times 0.8 is gonna give you 80 Newton, because the sine of 37 degree is given to be 0.6, the cosine of 37 degree is given to be 0.8. Now, how do we calculate the normal force? As we have discussed in other videos, the normal force is the force that holds the two surfaces together perpendicularly. Yes, so there is a force, pressing force of the above mass, and this is the weight of the object, the mass times gravity. But there's a force inclined at an angle. This is the force, but this force has two components, Fx and Fy. The y component of the force tends to detach these surfaces, so the detaching forces has to be subtracted, and the weight is tending to attack the surfaces. The attaching force is positive. So the normal force, the force that is perpendicular to the surface, this time is equal to how much? This time is equal to the weight, downward weight, the attaching force, minus the y component of the force, the detaching force Fy. So this is equal to the weight is 10 kg, mass is 10 kg times the gravity is 10, and the Fy is already calculated, it is 16 Newton. So this gives you how much? 100 Newton is the weight minus the detaching force is 60 Newton. So this is gonna give you 40 Newton is the normal force. The normal force that holds the surfaces together is 40 Newton. So by definition of frictional force, the small f is for frictional force. This is equal to the coefficient of friction times the normal force. This is 0.4 is the coefficient of friction times the normal force is 40 Newton. So you can write this as 4 times 10 times 0.4. 10 times 0.4 is 4 times 4 is 60 Newton. So this is the frictional force that resists your motion. The direction of the frictional force is always opposing the motion. So the acceleration is this direction. This is the direction of the acceleration. Then the frictional force is resisting your motion in that way. Now let's find out the resultant force. The resultant force is equal to the x component of the force applied. So this force, this is the Fx, minus the resisting friction. This is the frictional force. So Fx minus the resisting force. It is small f. So this is equal to how much? The Fx is how much? 80 Newton into the positive x direction, minus 60 Newton is the resisting. So this is gonna give you how much? It is 64 Newton, yes? 80 minus, yeah, 64 Newton. So this is the resultant force. Now let's get the acceleration. So the acceleration is according to Newton's second law, the resultant force divided by the mass, but the resultant force is 64 Newton and the mass is 10 kg, you know. So this is equal to 6.4 meter per second square. You can say Newton per kg, or you can say 6.4 Newton per kg. You know, from Newton's second law states that the force is the mass times acceleration. The resulting force is the mass times acceleration. So the dimension for the unit for SI unit of the force is derived from it. SI unit of mass times SI unit of acceleration. Yes, so that is SI unit of acceleration. So the SI unit of force is denoted by N, which is Newton, and this is equal to kilogram times meter per second square is the SI unit for acceleration. Now divide both sides by kg, so Newton per kg is the same as meter per second square. So you can use this expression for acceleration, Newton per kg, and meter per second square interchangeably for